This video about the respiratory system. We have air passages. It is nose and mouth that are openings that allow outside air to flow into the lungs, and also that when you exhale air, it goes outside. Pharynx, or throat, directs air from the nose and mouth to the larynx. Larynx, or other name voice box, directs air to the windpipe and contains vocal cords for vocalization. Trachea, or windpipe, splits further. It is this pipe, and further it splits into left and right bronchial tubes that direct air to the left and right lungs. Okay, here you see schematically represented nose, and then you have trachea and pharynx. It's again pharynx, here mistake, pharynx. And then you have this trachea is split into two pipes, through two bronchial tubes, left to go into the left and to the right part of the lungs. Lungs are two organs, left and right. And you have bronchioles. Bronchioles are small pipes that are directing air to alveoli. Alveoli, it is sacs for gas exchange. Let's look here in some more details. We have nose. Air can go mostly through the nose. It is not healthy at all if you are breathing through the mouth, because this is normally should be closed. These openings are closed normally. So if you are breathing through the nose, air getting easy to the pharynx first, and then from pharynx to larynx, to this voice box, and further to trachea, to windpipe here. And what is important for children to remember, that you have to breathe through nose, not mouth breathing. You have to practice nose breathing. If you breathe in through the mouth, and it can happen if you have respiratory diseases, respiratory infections, then your nose is inflamed, swollen, and air cannot go through the nose, and then all your head, all your skull is deformed. So your cheekbones are do not develop. You have crooked teeth because these bones do not develop. You have crooked nose. You have ugly face. And quite opposite, if you're breathing through nose, everything is fine. You have a good development of cheekbones here, and you have all the other bones that's jawbone develops very well, and you have straight nose, and you have very good looking face. Again, here other problem related with to teeth. Teeth do not because bones do not develop. Teeth do not develop. Teeth are deformed, and then they are. So some kids need braces because you see because of bones not developed, there is no place for teeth, and all head is getting ugly. The chin is receding, and face is very narrow, and that eyes are tired, and what is also very important, bad posture. Why it is happening? Because when you are breathing through the mouth, you have to open the passage for air, and it is possible only if your skeleton is deformed such way that you have a larger opening for air through the mouth, and then it is all your body will be deformed, and bones will not develop well. Very good if in young age already people practice exercises full breathing exercises. And this how it is done. You sit, just relax a little bit, not necessary to take this yoga poses. Just sit relaxed and breathe through the nose, but close one nostril with the finger so that you are breathing in slowly, breathing in full and full lungs, completely. And then when you finish, then you hold the breath for a while, and then you are breathing out also slowly, and again hold the breath that before you start to inhale the air. In my time, I mean, when I was young and at school, I was kind of a little bit crazy about swimming, about diving, and what I was practicing holding breath underwater. At this slide, man sits at the bottom of the swimming pool, but normally it is not happening because you need, if you keep hold breath full lungs, you cannot sit at the bottom of the swimming pool. You will get your buoyancy is high, and you cannot sit. So what is necessary to use weights or some lead or something so heavy, and then you sit. And when you are holding breath underwater, it is very important to control your heartbeat rate. You have to slow down your heartbeat rate, and if you can control your heart, then your brain gets enough oxygen, and you can you can hold the breath for long. I used to hold breath up to 5 minutes, but some people can hold breath even 10 minutes. So because why it is possible? Because lungs, because oxygen, we have a lot of oxygen in blood in inner organs, and if you can control your heartbeat rate, then blood is coming from your inner organs, especially from liver and pancreas, and then it is squeezed from inner organs and go to the brain. So it is safe, and you can stay for long with while holding the breath. Okay, let's go again to structure, to how these pulmonary vessels. We have lungs. The lungs have left and right side. So yes, this organ is doubled, and then it is in chest cavity. And chest cavity is you need to create vacuum and also to produce this gas exchange. And you have bronchial tubes. Bronchial tubes, as I said, one go to the left, another go to the right lung, and then you have smaller tubes, bronchioles, smaller tubes that direct air to small air sacs known as alveoli. Alveoli is this is sacs that are surrounded by capillaries, and then a gas exchange is happening inside the alveoli. And of course you have arteries, pulmonary arteries and pulmonary veins. So and arteries, they supply blood which transports CO2 enriched blood from the heart to the lungs, and the veins transport oxygen rich blood from the lungs back to the heart. Here the pulmonary circulation, and you see how the blood is getting from the heart to the lungs through arteries, and then through veins and getting back, and then then the heart pumps blood to aorta. So you have this very tiny alveoli, or the sacs of alveoli, and they are surrounded by capillaries, and all the gas exchange is happening inside the alveoli. Here we can see larger picture. So these are alveoli, and we have these tubes and passages for air. And what is also we have to pay attention, there is connective tissue. As I always say that We have not only cells in our body, we have about 85% of our body consists of extracellular matrix, and extracellular matrix includes, in particular, connective tissue, and it includes also mucus, it includes blood. So then this alveoli, they have not many blood cells, not many cells, but they have this extracellular matrix which keeps the shape of the alveoli. Here, and what can happen? What can happen if lungs are healthy? Then we have normal alveoli and everything is good, and but alveoles can be inflamed because there is chronic inflammation inside the lungs, or it is maybe some respiratory disease, respiratory infection, and of course we can have chronic disease, chronic bronchitis, and in case of chronic bronchitis, what is happening? All these air passages are getting smaller because at the inner side, on the inside of this bronchioles, there is a protective layer of mucus, and if we have too much mucus inside the bronchiole, then the air passage is small. Small air cannot go through very easy, and people have problems to breathe. So this people talk about chronic obstructive pulmonary diseases. It is a group of diseases that makes it difficult to breathe. So we can separate emphysema. Emphysema, it is when alveoli gets stiff and damaged. And if it is getting stiff, what means stiff? Extracellular matrix gets too much collagen. If it is too much collagen, then these alveoli are stiff. They cannot be stretched. They cannot be squeezed. So air gets trapped inside the alveoli. And next type of diseases is chronic bronchitis. Chronic bronchitis, it is swelling in the airways and increased production of mucus. This is different. So alveoli can be inflamed and can get stiff, and also bronchioli also can get more mucus, and then air cannot go easy through them. Here we can see again at larger magnification. Normal airway is so air can go through relatively easy. We have large area opening, large area passage for air, or otherwise it is asthma or bronchitis. We have this the layer of the mucus is too thick and air cannot go through. So people have problems, difficulties to breathe. What is happening? If you have normal airway, then this air passage is open and there is a protecting layer of mucus, but it is not very thick. But in case of inflammation and then chronic bronchitis, we have more special so-called goblet cells. Goblet cells, they produce mucus. And we have inflammation. Inflammation is caused by mast cells. Mast cells, they produce signal molecules such as histamine, and then you have inflammation, so it's more blood is coming to this area surrounding this bronchiole. And of course, because of inflammation, it is swollen. Okay, now here we can see normal lungs with alveoli healthy and good, elastic, so that they can be stretched and can be squeezed, and air getting in and out, so it works easy. Or otherwise, we have development of this of the fibrosis, and fibrosis develops mostly in older people. Why it develops? Because we have natural stiffness of the body because reaction of sugar molecules with collagen. Sugar reacts with collagen and cross-linking the fibers of collagen so that these fibers are losing elasticity and all the extracellular matrix gets stiff. And when your lungs are stiff, you cannot stretch them. What is happening with age, your so-called vital lung capacity is dropping. Vital lung capacity is dropping because whatever you do with your muscles, you cannot stretch your lungs. They are already losing elasticity. You try to create vacuum inside your rib cage, but it doesn't work. So, and in time, this vital lung capacity is dropping. But I know how to improve it. And in my case, people of my age, they normally have a vital lung capacity 3 liters, 600 milliliters or less. And I have a vital lung capacity 5 liters to 300 milliliters. Okay, much. It is yet not as good as in my young age, because in young age my vital lung capacity was 6 liters and 200 milliliters, or about this value. Now it is 1,000 milliliters less, but it is improving in time. What is good? It is improving. I know how to improve elasticities of the alveolus, and in time, slowly it gets more elastic, and I can breathe better. I can stay higher physical stress, and so it makes my body younger, actually younger. Maybe it is not so visible to skin, because skin is a special organ, but inside it is getting more elastic. What we know recently about this respiratory infections such as COVID, that some people die from cytokine storm. What is cytokine storm? Cytokine storm, it is we have mast cells inside our lungs and inside all our tissues, and they are like garden cells. They react on damage of the tissue. When they get signal about damage of the tissue, they release signal molecules. Mostly it is histamine, and this is a signal molecule that attract immune cells and attract the stem cells to come and to repair the damage. Stem cells are supposed to replace damaged cells, and immune cells are eating and providing nutrients for stem cells. They destroy the damaged cells or infected cells, and they provide these nutrients to stem cells, and stem cells repair. But in time, because of reaction of sugar with collagen, all our extracellular matrix getting stiff, and the migration of the immune cells and stem cells is getting more difficult. It is obstructed. Therefore, we have in old age, stiffness of the body is increasing, and especially in lungs, it is very, very dangerous, because we have not only higher stiffness of the lungs, but we have this reaction of the mast cells, and when mast cells produce this signal molecules, then what is happening, goblet cells produce more mucus, and then all the air passages are getting closed. Okay, let's see. Cytokine storm. In normal lungs, sometimes the cells of the epithelium are getting damaged. But what is happening is that mast cells produce signal molecules, and then immune cells are coming and destroy this damaged cell, and the stem cells replace the damaged cell. But if there are too high concentration of these cytokines, of this histamine, then very many immune cells are coming, very many cells of epithelium layer are destroyed. They try to eat these cells, and what is also happening, that inflammation give a signal to goblet cells. It was somewhere. Look, wait. goblet cells. Here. It gives signal to goblet cells to increase production of mucus to protect the lungs. But instead of protection, we are getting conditions that there is no gas exchange through this very thick layer of mucus. Okay, then people can die. So this cytokine storm can happen as a reaction to virus, but also as a reaction to vaccine sometimes. What is important? We were talking about that we have protecting a layer of mucus, and it is very, very important that we have to protect epithelium layer in the lungs, and also we have to protect so-called endothelium layer in the capillaries from damage. And this in capillaries it is done by layer of mucus and layer of so-called glycocalyx. Glycocalyx, it is both long molecules which look here like fibers, and this layer of mucus. It is very thin. It is half micron size only. The thickness of this protecting layer, but it's very, very important. Why? Because about 15 years ago, I was yet working in fluid dynamics, and I discovered it is actually a new physical phenomena discovery, it's big discovery, that if you put viscoelastic fluid, what is important? Elasticity is important. If you put viscoelastic fluid on the inside of the pipe, then you can reduce friction inside this pipe. Dramatically reduced. So later on I proposed such advanced lubricants to be used in engines and to reduce friction in engines, to reduce wear in engines, so that engine can save fuel and engine can work much longer, because wear reduced is like 50 times. But industry, unfortunately, is not interested to save money. They are interested only to increase profit. As any business, they want to increase profit, and then they didn't see how they can increase profit, and they are not interested to save money, they are not interested to save resources, so it was not supported anyhow. Even some scientists they appreciated my discovery, and some people yet trying to work in this area, but at my university, unfortunately, I didn't get enough support, and all the Germany came to very hard times, so I stopped this research, and even with lubricants, industry was not interested, and now we have other solution to all the problems. We have to reduce population, and it goes much more easy, because to kill people it's relatively inexpensive. So what we have inside blood vessel? Capillaries can be very, very thin. It can be less than 10 micron diameter. You see here scale 2 micron, and this diameter is of the capillary about 10 micron, but actually they can be even small diameter. And we have this glycocalyx layer with mucus. Glycocalyx is not only viscoelastic layer of mucus, because elasticity is provided by these long fibers. It also has sulfur atoms, and sulfur atoms are electrically charged, and they electrically pull out the red blood cells, and red blood cells can go through the capillary with almost no friction. This is so important. This is so important because if you have no friction in your circulatory system, your heart is not overloaded. Your heart is relaxed, it is working easy, and you don't have high blood pressure. Like I have very low, but I have blood pressure like of an infant. So elasticity of my blood vessels is so good, and then you have this protecting layer of glycocalyx is so good that I know what to do, and it works for me. For other people, maybe not, because again, it is not free information. Okay, so but I know what to do, and I I do it well. And then if even in my age, I have no problem with blood pressure, I have no problem with physical stress, and then at least inside I am getting younger. In time I'm getting not older, but I grow younger. Okay, what is happening then? As I said, no friction inside blood vessels is very, very important. Also, if gas exchange goes through this wall, we have to make the thickness of the mucus layer very thin, but yet it is permeable for oxygen and CO2 for gases. Okay, and the same problem, but this layer we have named endothelium, and in the lungs, because here is the blood, and if we have air in alveoli, then name is a little bit different, but it works the same, but name is just epithelium, endothelium. Endothelium if it is blood inside, and if it is air, then it is epithelium. Like skin also have epithelium. And epithelium cells, they also have this protecting layer of mucus, and it should be, it is protecting the lungs from damage. Okay, we will go to this a little bit later and also in other videos, because it's a very important question and I know how to do it, and medical professionals never will tell you what to do, never. Okay, but I am doctor in science, and I'm mostly interested to keep myself healthy. Okay, then we have the muscles. We have diaphragm, which is the largest muscle in the respiratory system, and then we are pumping air to the lung and outside the lung, yes, so inhaling and exhaling. But we also have muscles which are pushing rib cage. Yeah, okay, so what is happening? Muscles are pulling ribs up little bit, so, and because ribs are connected to this bone, then when you pulling ribs up, the volume of the rib cage is increasing. You're inhaling air. You're inhaling. Yes, you inhale, and diaphragm also contracts. It is moving down, and then you create vacuum inside the rib cage. And then what is absolutely important, that we have respiratory system. So we need these muscles and to work, and diaphragm to work for breathing. But we also need this vacuum to pump lymph from our guts, especially from our guts, to then through the lymphatic system, and then through the lymphatic system to the vein and to the heart. Okay, and then opposite exhalation of air gets to be exhaled when muscles are relaxed and diaphragm also relax, and then it is moving up. Okay, then we exhale here. Okay, we will not go too much on it, but we see that because of this structure of our ribs, rib cage can widen, so create vacuum, or it can also reduce volume. And air can get in or out from the rib cage, and we have working of diaphragm. What is okay? We will not go too much on these names, Latin names of the muscles, but what I wish to pay that you will pay attention to special exercise which help to keep you healthy, to keep your lungs healthy, and especially to increase vital lung capacity. Because you make an alveoli more elastic, but you also stretching all your lungs, and your rib cage is getting bigger, and also the vital lung capacity is increasing. This exercise is so-called vacuum inside of the rib cage. So this girl shows how to do it. You exhale air, and then you stretch, you push your diaphragm and try to stretch to stress your diaphragm and other muscles the same like you are breathing in, but you are keeping air from entering. So you create vacuum inside of the rib cage, and then the lymph is going up very easy. Also the blood in veins is going up very easy. So it works like a very big help to your heart, but also very big help to clean your body from toxins and to keep your lung capacity higher. And so it is a very, very helpful, very good exercise. So try to do it every day, maybe a few times. We have to also to consider gas exchange and breathing for fish. Fish don't have lungs, but they have gills. Gills working so that they have such plates or lamellars, and inside every lamella there are these capillaries, and water is flowing between the lamellars, so that there is gas exchange. Oxygen getting in and CO2 getting out, and fish are breathing with oxygen which is inside water, in water. They are not breathing with air, they are breathing with oxygen which is in water. There is, however, a very special fish, people call it river monster. It is in Amazon river, Arapaima. Arapaima, it is a very big fish. It can be 50 kilo weight, and it can breathe air. It can breathe air, and it is very interesting done. So they don't have lungs for sure, but they have swim bladder. Swim bladder. Every fish have swim bladder, but this fish have large network of blood capillaries inside the swim bladder. So there is a gas, what is going, gas exchange inside of the swim bladder, and then fish is breathing in to the air to the swim bladder and using as a lung, and breathing out, squeezing it, getting air out, getting fresh air. And so far the fish can stay in muddy water with also hot. If sun makes water hot, it's not a problem. So they can stay in Amazon river and can breathe air instead of oxygen from water. And next and the last about breathing of lizards and frogs, and so they have lungs, of course, they have lungs, but mostly gas exchange goes through the skin. So oxygen go in, carbon dioxide go out, and this is why the surface of the skin of these frogs and toads is covered by mucus. It is like wet, and this is for two purposes. First purpose is to protect skin of the frog, and second it is to promote gas exchange, because gas is going through the layer of mucus. If skin is dry, air cannot go in, and oxygen cannot go in, and carbon dioxide cannot go out. So that's all. So to conclusion, you see that what is very important, it is protecting layer of this glycocalyx in blood vessels. It's very important. This mucus, we need mucus, but not too much, because if we have chronic inflammation, then these goblet cells, they produce too much mucus. There can be asthma, there can be chronic bronchitis. And what else important? Fibrosis and stiffness of the lungs. This can develop mostly in older age. This develops because of reaction of sugar molecules with proteins. Yeah, with proteins, and then you cannot. So to reverse this process, it's very difficult. So this is why older people losing vital lung capacity in time. So the volume of air which they inhale and exhale is getting smaller with age. And in my case, I know how to improve it. And in my case, I slowly, from some years before, I slowly increase my vital lung capacity because I know how to make my body, at least inside, how to make my body younger. Then I believe that in time I can grow younger, not older, and I can live much longer than normal people do. But this is science again. This science is not free. It is, as I said, problem with the science that it needs money. And even if I propose something important and interesting for people, like to save resources, to save our planet, for example, then it is nobody is interested. Everybody interested only to make money, and making money is a different business. Business is not moral. Business is you can see medical care. It is business, so it is not that the medical professionals try to save your life or to make you healthy. No, they try to make money. And I know this. I'm doctor in science, and but at least science give you answers, give you knowledge what to do. And if you don't want to learn any science, you probably will never have good health and will suffer from all diseases which we are getting from infections like pulmonary, all these infections. And again, what is I was always talking about, sugar. If your diet is based on carbohydrates, then because of high concentration of sugar in blood, your stiffness of your tissues or your skin and lungs is increasing in time because of the reaction of the sugar with collagen. And collagen is main fiber, main protein which keeps shape of our body. We have shape of our body, special shape, because we have collagen fibers. Collagen gives us this frame for our body. And if this frame is getting stiff, then we are getting problem that nothing can work, especially if lung fibrosis is deadly. And plus, cytokine storm can happen. Cytokine storm, it's overreaction of your immune system to infections. Also can happen, and some people die from this. Okay, so mind that it is the knowledge can save you, and science can save you, can help you, but ignorance is deadly. Okay, that's all. Thank you.